Graph the quadratic function y equals x squared minus 4x plus 3. Well, in order to graph a quadratic function, we have to follow 4 steps. The first step is that we have to determine the concavity of the function. That is, we have to determine whether the function is concave up or concave down. Secondly, we have to determine the y-intercept of the function. So we have to figure out when the graph of this function crosses the y-axis. The third step is to determine the x-intercepts. Now, this section only examines functions which have 2 x-intercepts, so we know that there'll be 2 x-intercepts for this function. And fourthly, we need to determine what the vertex is. So the vertex. Once we have all these features of a quadratic function, we can then go ahead and plot the quadratic function on a set of axes. Okay, let's start. Let's have a look at the concavity. Well, you might recall that if to determine the concavity of this function, what we have to do is have a look at the coefficient on the x squared term. And if this coefficient on the x squared term is greater than 0, then the function is concave up. If it's less than 0, it's concave down. So here we could easily write this as 1 times x squared. In other words, this x squared variable has a coefficient of 1. So because the x squared variable has a coefficient of 1 and 1 is greater than 0, we can state that this function is concave up. And because it's concave up, we know that the function will look something like this on this set of axes. Okay, let's move on to the second step. Let's determine the y-intercept. Well, we could substitute x equals 0 in here, but an easier way to determine what the y-intercept is going to be is to remember that y-intercepts always have an x-coordinate of 0, and that's because the y-intercept is the point at which a graph crosses the y-axis, so by definition it must have an x-coordinate of 0. And if we were to substitute x equals 0 in here and x equals 0 in here, this part of this equation would be 0, which would just leave us with this final part, this constant term. In other words, we can quickly say that we know that the constant term is going to be the y coordinate of the y-intercept here. Consequently, we can say that the y-intercept is going to be 0, the x coordinate of 0, and the y-intercept is going to be, or the y coordinate of the y-intercept is going to be 3. Let's go ahead and plot this on this graph. So 0, x equals 0, that's going to be 0 units left or right of the origin, and y equals 3, that's 3 units up. In other words, this is going to be the y-intercept of the function. Okay, we're roaring through. Let's have a look at the x-intercepts. Well, in order to find the x-intercepts, what we first have to do is factor this quadratic function. So let's do that. In order to factor the quadratic function, we have to think about what 2 values, when multiplied, equal positive 3, and when added together equals negative 4. So what we're trying to find is we're trying to find some factored form where we could write this equation as x plus a, x plus b. And if we were to multiply this out, we get x times x is x, plus x times b is, x squared. We get bx, a times x, we'd get ax, a times b is ab. If we collect common terms here, this simplifies to x squared plus a plus b, x plus ab. So in other words, what we need to find is a value for a and a value for b, such that minus 4 equals a plus b, and plus 3 equals ab. Well, looking at this equation, if we're thinking about what values we could input such that ab equals 3, there are really only a couple of different values. We could have 1 times 3 equals 3, or alternatively we could have minus 1 times minus 3 equals 3. Well, here 1 plus 3 equals positive 4, whereas minus 1 plus minus 3 equals minus 4. So it's quite clear that minus 1 and minus 3 are going to be a and b here, which means that we can rewrite this expression as y equals x minus 1 multiplied by x minus 3. So this is a factored form of this expression. And if we wanted to check this, we could always expand this expression. We find that if we expanded this expression, we'd get the same expression up here in yellow. Okay, well, quite clearly then, we have to, or what do we have to do next? Well, to find the x-intercepts are going to be the points at which this graph crosses the x-axis. And so by definition, we're going to have those x-intercepts are going to have a y-coordinate of 0. So in other words, to find the x-coordinates, we simply set y equals 0. So at y equals 0, we have 0 equals x minus 1 multiplied by x minus 3. So the question is, what are the values we could substitute in such that this statement is true? Well, there are two values. We could substitute x equals 1 in here, and this would be 0 times something else, which would all equal 0. Or we could input x equals 3 here. And this part of the equation would be 0. This would be some real number. A real number times 0 is 0. In other words, there will be two x-intercepts. Both of them will have a y-coordinate of 0. The first one will have an x-coordinate of 1, and the second one will have an x-coordinate of 3. So these are the two x-coordinates for this function. So let's go ahead and graph them on this graph. So here, 1, 0, that's going to be 1 unit right of the origin, and 0 units up or down. That's going to be just here. Whereas 3 and 0, that's going to be 3 units right of the origin and 0 units up or down. Okay, so far we've discovered it's going to be a concave up function with a y-intercept of 0 and 3 and 2 x-intercepts. All we have to do now is find the vertex. Well, to find the vertex, the first thing we do is determine the x-coordinate of the vertex. The x-coordinate of the vertex is going to be the average of the two x-coordinates of the x-intercepts. In other words, it's going to be the average of 1 and 3, because these are the two x-coordinates of the x-intercepts. Another way of writing this, we can simply add these together and then divide that addition by 2 in order to find the average. So we can find 1 plus 3 over 2. That's the average of 1 and 3. So 1 plus 3 is 4. So simplifying this yields 4 over 2. 4 divided by 2 equals 2. So the x-coordinate of the vertex is going to be 2. In order to find the y-coordinate of the vertex, all we need to do is substitute this x-coordinate into our original function and then solve for y to figure out what the y-coordinate is. So here we'd have the y-coordinate is going to be equal to x squared minus 4x plus 3 when x equals 2. In other words, 2 all squared minus 4 times 2 plus 3. Let's simplify this out. 2 squared is 4, minus 4 times 2, that's minus 8, plus 3. Okay, we're going to have 4 minus 8, that's minus 4, plus 3, that's going to equal minus 1. In other words, the vertex will have an x-coordinate of 2, a y-coordinate of minus 1. So the vertex is going to be the point 2, minus 1. So that's going to be our vertex. And let's plot that on the graph. So that is going to be 2 units right of the origin and 1 unit down. Okay, the last thing we need to do is actually graph this parabola or this quadratic function. So we can join up these dots. It's going to be concave up, so it's going to look something like this shape. And we're going to put an arrow here and an arrow here. So these are always the 4 steps you need to go through in order to graph a quadratic function. So if you ever come across a quadratic function that you know has 2 x-intercepts, these are the 4 steps you have to take.